Hello, everyone. Boa tarde a todos. Bem-vindos a mais um webinar. Eu vou mudar agora para inglês, por ser um webinar internacional. So, welcome, everyone. This is one more CBT webinar. This one is international, it's in English. Still, I would like to kindly ask you, if you haven't done so, to subscribe to our channel. We have several webinars, several subjects in tunneling. Most of them are in Portuguese, but some of them we try to do in English, and we invite our international colleagues. Please give like to the video as well. And just in case you're going to be here in Brazil, in São Paulo, we are going to have our tunnel day on Friday the 2nd. And it's just in the morning time because afternoon Brazil is going to play against Cameroon. So we're going to celebrate, probably hope that Brazil wins. And we're going to be celebrating that together in the tunnel day. Tonight, we're going to have a very good colleague, a friend that I have done the PhD while I was in Bochum University. He was also there doing his PhD in Bochum, also with Professor Davis. And we're going to have Zdeněk Ziska. Zdeněk currently works as a senior tunnel engineer in a design company, Metro Project, based in Prague, Czech Republic. The company focuses on complex design of underground structures. Zdeněk works includes all stages of design from feasibility to construction, dealing mostly with railway and subway tunnels. He has also worked for Midel Tunnel Consultants, and he has completed a PhD at Bochum University. Please, I would like to remember that in the end of the session, we have a time for questions. Send your questions here in the chat. And I would like to welcome Zdeněk. Welcome, Zdeněk.
Hello, everyone.
And I'm going to put your presentation here. And please, the floor is all yours.
Thank you, Daniel. It's a great pleasure for me that I can present here today for the Brazilian Tunneling Association. And I will give two presentations. The first one is about a railway tunnel in Prague. And the other one is going to be about the new subway line, which is going to be constructed soon in Prague. So here's the structure of my first presentation. First, I will start with some introduction. Then I will tell you about the development of the road variants. I will give some details about the tunnel and also discuss the geotechnical conditions. And then I will talk in detail about the tunnel underpass of Svatovická access ramp. And I will close my presentation with some concluding remarks. About the entire project, this presentation is called the selection of the road for railway tunnel in the center of Prague. So this tunnel, what I'm going to talk about, is a part of a larger urban railway network, which is connecting. Here is it, better to see, which is connecting the center of Prague and the airport and the nearby town Kladno, which is basically a suburb of Prague, because a lot of people are traveling every day from this city to work in Prague. And there should be established a new railway connection, and this new railway connection will have a stop also at the airport. So here are some impressions of the projects before I'm coming to the tunneling stuff. One railway station in Prague as part of this project. Another station here is possible to see that is partially underground, partially above ground. Here the same station from inside, and here some impressions for the upgrade of the railway station in Kladno. And the last station will be there also at the airport in Prague. So I'm getting back to the tunneling stuff. Here I will focus on this problematic section, which is supposed to be entirely in tunnel. And there are some interesting interfaces. For instance, at the start of this section, you have an interface between this new rail tunnel, which is the subject of this presentation, which has to be constructed just next to existing road tunnel, and under it there is a located subway station. So it's very dense area, and everything has to be interconnected. So I'm coming to the development of the road variants. Before talking about it, I want to provide some excursus into the design stages in Czech Republic. How is it defined by the construction law? First, what you have to do is the feasibility study, and including technical economic assessment, and then you go for the preliminary design stage. And when you submit this preliminary design to the authorities, you ask for the issuing of the so-called zoning decision. And what is important that at this stage, only one variant of the project is possible. After that is coming detailed design, and this detailed design is then followed, if successful, by the issuance of the planning decision. And after that, tender design is provided, and this is the basis for awarding of the construction work. Because as typical, you have within Czech Republic the contract type design big build. So we have some design and build contracts, but I think there is just one. So let's talk about the tunnels between Veleslavin and Davice in Prague. They were at the start. It all started in 1995. There was a feasibility study for the surface variant, which is the variant U1, until 2005. There was preliminary design done for the variant U1, but as a cut and cover tunnel. And there was a problem with the cut and cover tunnel that it's going to bring too many construction work into this dense populated area, and it will disturb the inhabitants. So there was new technical and economic assessment in 2016, and there were three options followed. First option was again the cut and cover tunnel, U1 under the contemporary track. Then U2, this was cut and cover tunnel partially under the contemporary track, and the new variant was tunnel tubes under the so-called Střešovice plateau. So this variant with long tunnels, kind of like, I would say, base tunnel, but it's still not so very high cover as in the Alpine tunnels, but it might be a base tunnel because it's going from one valley to another valley under the hill. So this variant was preferred, and since 2018 there is a drafting of preliminary design documents. So during the 2019, we had we designed this variant, and we had the negative statement from the Institute of Physics because they were afraid of the tunnel if it's going to be constructed and especially operated under the Institute of Physics. It will destroy the possibility of the institute to conduct some precise physical experiments due to the vibrations and some background noise caused by the tunnel. Yeah, well, so there was a slightly different variant, so-called North New, which was shifted a little bit towards north. But there was another problem that in this area, at the start, you go very close to private properties, and this was considered as quite a high risk for this tunnel variant. So it was decided to find a new variant, the so-called South, and this variant is using the Střešovice plateau as much as possible and is trying to get as much cover as possible. So we made this variant, we presented it to the public, and the public was not satisfied with this variant. So we made again elaboration of multi-criteria comparative study. We considered not only this variant South, but we considered also variant cut and cover and the other board variants, which is this orange, so-called variant center, and the variant north, the original one. We asked for other subjects for elaboration, second opinions for topics like hydrogeology, impact of tunneling on the surface structures, and impact of vibrations during operation from the railway tunnel. It turned out that, as we expected, and also what our multi-criteria evaluation delivered, that the variant north is the best in all aspects. So we followed this variant. So now I'm going to say something about the tunnel in detail. It is planned to be 2 single-track tubes excavated by TBM under populated area. Here on the right side, you can see the longitudinal section of the track. And now I will show you a video. I hope it's working. How the tunnel will pass under the Střešovice plateau. Here you can see at the start that the cover is about 30 meters and is going to increase very fast. And when it arrives to some populated area, the cover above the tunnel is at least 45 meters. So when it's going under the church, it has covered 60 meters of quite competitive rock. So at the end of the tunnel, the cover is about 70 meters. And now we are on the deepest point under the Střešovice plateau. So we are at the end of the stretch, and the cover is decreasing again, and we arrived in to the tunnel portal, which is then followed by another cut and cover tunnel. So here's the alignment of the tunnel. Some interesting features along the alignment. First complicated section is that you have to underpass with these TBM tunnels, so-called access ramp to a road tunnel, which is located here, which is in cut and cover. Then you have to pass around the tunnel Blanca, which is a road tunnel, here on this place, you can see the failure of the tunnel, which happened during the construction of this road tunnel. So this is what we all would like to avoid. Then we are passing close to the Institute for Physics, but the distance is more than 100 meters, so that should be fine for the physicians. We are passing under the church. Here we've covered 60 meters, so that should be also fine for the church by limiting the surface deformation or on the axis on the allowable under the allowable limits. Due to the fact that at the starting tunnel portal of this TBM tunnel, there is a cut and cover station, and on the other end, there is also part of cut and cover stations. We have to have in this tunnel a ventilation shaft for the emergency purposes. This tunnel is 3 kilometers long, so usually it wouldn't be a problem due to the safety, but in this case, we needed to introduce it. So here is the second part of the alignment. Here it's necessary to pass under the hospital, but the cover is here above more than 70 meters. And then at the end, when you're arriving to the portal area, you pass around heating power plant. So something about the tunnel cross section. There will be excavation diameter expected 9.9 meters. The internal diameter 8.7 meters, segment lining thickness 45 centimeters with EPDM gaskets. And in this current stage of the design, is not decided whether it's going to be reinforced concrete or it's going to be steel fiber concrete. This is going to be defined in the next design stages. What is interesting, we have a railway tolerance, which is necessary according to the Czech norms for the railway, which is 30 centimeters. And what is possible is to include in this 30 centimeters also the driving tolerance for the TBM. So which is saving some centimeters of the cross sections. And what is also interesting, or like it's necessary, good to mention that there is going to be slab track in the tunnel. So here are the cross passages every 500 meter, based on the European law, nothing special. And there will be not only the cross passages, but at the start and at the end of the tunnel, there are 2 technological objects, and they can be used also as escape routes. Here's again the ventilation shaft. It's going to be about 60 meters deep, with the internal diameter about 8 meters. And it's going to be used only for emergency ventilation. And it's not going to be possible to use as an escape route. For escape, there should be used only the cross passages or the escape routes at the portals of the tunnel. This is designed as with steel fibers for the primary lining and maybe for the secondary, but the owner has still decide if it's going to be allowed also for the secondary lining or not. And for the structural design purposes, at this early stage, we considered the lining as unreinforced, so not considering any benefit of the steel fibers yet. Now I'm coming to the geotechnical conditions, and the geotechnical conditions of this project are quite interesting. You start here and at the launching pit within soft ground. There's going to be a soil which is which is quite soft here, and then you enter the soft rock, which is typical for Prague, and it is shale, and there are several formations of this shale called Latin shale or Dobrotiv shale, and this rock base is covered by claystone, and it's covered by sandstone. What is interesting that this sandstone is collector for groundwater, and this claystone is isolator. So you have here two levels of the groundwater level, one within the shale and another one in the sandstone. And what is very crucial for this area that you shouldn't allow the connection of this groundwater tables. Here is shown the 3D geological model what we have prepared for this project. As we thought, or the intention of this 3D model in this very early stage of design is that the model should increase the public acceptance of the project and to reassure the citizens about the safety of their properties. So the point was to show to the public that we are sure what we should expect underground, or at least as sure as possible, and that we know what we are doing. Here are some details about the model. It's based on the Czech coordinate system. So this is quite specific coordinate system, and it combines all new and old bore log data. And what is important, that this model is possible to develop in the further design stage of the project. So we have started with this quite simple model, although there was very lot of bore data included in this model, and you can extend this model in every next stage. From this 3D model, you can extract directly 2D cross sections, and the model enable us to calculate automatically also the excavation volumes in various types of rocks. This model could be seen on the website, so if you are interested, check this website, and you can go through in 3D through this area and see what are the rock conditions expected. I would like also to mention that this model was established in cooperation with Czech Geological Survey, which put all the information together and established the model. So the last topic of this presentation is the underpass of Svatovická ramp. The Svatovická ramp is located close to the start pit for the TBM excavation, and it is here. And as I said already, it is an access ramp for a road tunnel nearby. Here is the picture of the ramp, and it's constructed partly with retaining walls at the side, and partly with diaphragm walls, and with the concrete slab on the top and in the bottom. So here is the cross section in this area. Here you can see the lamellas of the D walls, and here is the retaining wall. And the alignment of the TBM tunnels is planned in that way that we are coming up to 2.1 meters close to the bottoms of the lamellas. What is the problem of this diaphragm walls? That it's at the top of the lamellas there is a concrete slab, and this slab is again loaded by the soil cover, and it causes the situation results in high point loads under the tips of the D walls. So also in case if we would drive here with the TBMs with face support, with active face support, there will be definitely deformation of these structures. Here's the cross section of this D-wall tunnel. As I said here, the top slab, D-walls, and the bottom slab. Here is the cross section of the retaining wall, which is quite simple. Just the retaining wall, angular retaining wall on both sides. Nothing special. Road construction inside. So you have within the cross section, you have two different situations for both tunnels, here and here. So going back to the layout, so we decided to sink a shaft here before the crossing of the ramp and make for the left tube so-called pipe roofing, and for the right tube to make horizontal micropiles. So here is it in the cross sections. Here on the left tube, you can see the pipe roofing from steel tubes with diameter approximately by 1.3 meters. And here on the other side, you can see the horizontal micropiles. There are different reasons for using these two different additional measures. The steel tubes on the left side are used to stabilize and distribute point loads from the D-walls, and the micropiles here on the right side are used here to distribute the support pressure along the jump in the terrain and enable higher support pressure when the TBM is going to pass under this retaining walls on the right side. So here's the summarize the sequence of the measures: excavation of the construction shaft, execution of grout body, installation of micropiles, steel tubes. Then there will be a shotcrete excavation under the steel tubes, and this shotcrete excavation will be then subsequently filled with a poor, so-called poor concrete. So the TBM will pass here on the left within the open mold inside this kind of like concrete body. On the right side, the TBM will pass here in the closed mode. But the question is how the pipe roofing could be installed in this very dense conditions, where you have a pit only on one side, and on the other side there is not possible to place any construction pit. The other boundary conditions are tight tolerances, presence of soft ground and hard rock is possible, and a possible concrete rests under the D-wall tips. So the only solution which was possible for this area was the so-called retractable TBM. What is the retractable MTBM? It's a micro TBM which can be, after boring, which could be pulled again back to the launching pit. So this is there are two principles. One principle is that the outer ring of the cutting wheel is let in the ground with the shield, and another principle is that the cutting wheel decrease the diameter and then it's put back. So concluding remarks of my first presentation. In September 2022, the zoning decision is still not issued. The construction is planned for the 25 till 28. There is a very good cooperation with the client. We try to be as much transparent as even possible with the public, to talk about the risks, to talk about the benefits of the projects, and we try to equalize and to emphasize that we are doing to decrease the risks for the public as much as possible. But there is also the risk for the project that the politics will decide to stop the project, or the citizens will be so much against it that it's not going to be happen that we will go once from the airport to the city center by train. So that was the first presentation. I'm not sure, Daniela, if we should now wait for some questions, or should I continue with the next presentation?
I guess you can continue with the next one, and then we
All
check.
right.
Unless somebody wants to send, if somebody has any question now, if you can send in the chat. So far, we didn't have any question, but so I would say you just continue.
So here's my second presentation. Is going to deal with the new metro line in Prague, which is now already partially constructed, and another tender for the construction is running now, and the third part of this new line is still under design. So this presentation is divided in three parts. First, there will be some basic overview. In the second part, there will be it will focus on mining stations which are on this line, and the part 3 will focus on TBM escalations. So the basic overview. Here on the left, you can see the development of the network in Prague. Here you can see the years, how it was going. First, it started with line C, then it continued with line A, and as the third one was the line B. And here you can see it year by year how the network was increasing. So here we are now at this stage, and we are now talking about this line, the blue line, which is called line D, and is going to start at Náměstí Míru station in the city center and end in the south of the city in so-called Depot Písnice. So let's get the work done and make the design. That was the statement. There were going to be 10 stations to design and one depot. So I will go now through the entire line and talk about the different stretches and what is going on now in these stretches. The first stretch is between Obrechto and Pankratz. This contract was already awarded to Subterra, Hochtief, Strabag, and Siblin. The construction works started already. The second stretch between Nádraží Krč and Depot Písnice is now under ongoing tender. Here under these colors, you can see already the different excavation methods which are going to be employed during construction. It is better to see on this longitudinal section between the station Nové Dvory and station Pankratz. Here first, this is the first contract which is already awarded. There is everything conventional. You can see also the conventional excavation of the stations. Then it's followed by a cut and cover station, and then the rest is going to be done by TBM. There will be only one mined conventional station and one another cut and cover station. It's possible to see again in the layout the rest of the stations. Here again, mined station Nové Dvory, and the rest cut and cover. When it goes on the other side, here is again the longitudinal section. Nové Dvory station mined, running tunnels between the stations, all TBMs. and the stations, if they are close to the surface, they are going to be cut and cover. Here is the third part of the D line between Pankrat and Náměstí Míru. There is going to be the excavation, probably conventional, and one cut and cover station and another conventional excavated station. Here's the cross section. As you can see in Prague, there are quite different elevations to be run through. So you start with one station on the elevation 260 meters, then you have to pass a valley, which is like 70 meters lower, and then again there is another hill, and you are almost back on the same elevation as you was at the start of the other valley. So usually it results in typical layouts of the Prague metro, that under the hills you have quite deep stations, and in the valleys you have shallow stations to get the trains pass through this longitudinal slope. So here is the summary of the excavations. There will be 2 times about 6.2 kilometers of TBM excavation. The conventional is planned about 5.6 kilometers, and cut and cover about 1.8 kilometers. Here are shown some impressions of the stations. It's necessary to say that the entire line is going to be operated as driverless, so therefore you can see the doors at the platforms, and the typical color for this line is going to be the blue color. So now I will focus on the main stations. There are several main stations. First is Náměstí Míru. There will be junction to the metro line A, and the station is designed as single walled. The next station is Náměstí Bratří Sinků. The final variant is not yet decided, so I will not talk about that. Here's the station Pankrat. This station is already under construction. It's going to be single wall station, and there is going to be constructed a junction to metro line C. The next station, which is already under construction, is called Olbrachtova. It's going to be double wall station, and as I said, the construction already started. The next big main station is Nové Dvory. This is going to be single wall station, and it's necessary to establish there also the possibility to make an appendix to D line to area of Modřany. This is the district of Prague, south, close to the river. So these are all main stations. Here's again the longitudinal section. I will not talk again about that. So let's start with the station Nové Dvory. It's going to be single walled main station with island type of platforms, and with the cover about 33 meters, 2 surface entrances, and barrier-free elevator. And it's going to be important interchange to suburb buses. So there will be also a parking slot for cars. There is some questions from one audience, which type of waterproofing there will be. There will be used conventional waterproofing, just the membrane. Design includes the possibility in the future to construct an appendix of line D. So here's the layout of the station. At the top, you can see the parking slots. Here the entrances, 1, 2, 3. Here's how it's going to look like under the surface, the layout. Here's the possible switch to appendix of the D-line. And here the longitudinal section of the station. You can see the area for the public with the platforms, and here's some technological background of the station. Here it's possible to see the cross section of the station with some impressions about the size of the cross section. So the cross section area is going to be 280 square meters. Then the cross section with the escalator tunnel. The cross section area more than 400 square meters. And the maximum cross section, which is shown here, it's more than 420 square meters. It's going to be excavated conventionally and with sprayed concrete as first layer and cast in situ as the second layer, as the permanent lining. There will be a conventional or waterproof membrane between these two concrete layers, so nothing so much new. This system was already very successfully used on other stations in Prague, so the owner decided to keep the system and not to make any new experiments. There is again a question from the public. Will the TBMs pass through the station or prior to the station construction? For this case
I
of the
think
novel,
we have some questions. I don't know if you wanted to, or let's go the entire presentation and then we show the questions.
yeah, I can discuss it when I'm here, because I can use, for instance, this cross section to show it here. In this site edits, there is a plan to that the TBMs can pass, and this station will be constructed prior to the TBM arrival.
Yeah, so Werner is asking something related to that. So he has two questions. I don't know if you passed already, but what type
Yeah,
of waterproof?
I discussed that already several slides before.
Yeah, I don't know if so. What type of waterproofing proofing will be used in the stations? You already said.
Mhm.
And then I don't know if you want to say anything more, but he says, will the TBM pass through the stations or prior to station construction?
Yeah, here for this station, the station will be constructed first, and the TBM will pass when the all primary shortcrete lining is already installed. There will not yet be installed secondary lining, but only just the primary lining. So let's go to the next station. Olbrachtova is the double wall station, and it's about 30 meters under the surface, 2 accesses, and interchange to the bus lines and tram lines. Here, the surface, there will be the access, 2 accesses to the station. Under the surface, the layout of the station with 2 accesses. Here again, the public area and the technological background. Here the longitudinal section of the station is everything mined. The geotechnical conditions are characterized by shale. And here are the cross sections. As you can see, this is the double wall station. So the cross section are much smaller. And here you can see the shaft which is used for the construction of the station. Here, one of the most complicated area is the station Pankraz. Sorry. On the blue line, on the D line, which is to be constructed under the current under operation Metro C line. This is constructed in cut and cover, the station, and the excavated tunnels. So here's the 3D model of the station. It's the single wall station, so it's a very big cross section. And here again, the public area, the line C station, and the technological background, which is very huge on this station. The surface after the construction, here again, longitudinal section of the station. Here you can see here is the cut and cover metro line C. There is about 5 meters between the constructions, and here you have about 10 meters under the high-rise buildings.
I think Werner, if you so just taking the chance, Werner has another question. Same question about the TBM passage.
Here on this stretch there will not be TBM. Here at this stretch between Pankraz and Olbrachtova, the running tunnels will be excavated conventionally. Here are some impressions about the cross sections again. The basic cross sections is about 23 meters. The maximum cross section, there is more than 500 square meters, and the interchange passage about 140 meters. And what is necessary to mention that the part of this interchange was already constructed during the geotechnical survey campaign, which was done here on this station, not only to explore the geotechnical conditions and to get the parameters, but also to test the grouting measures. Based on these in situ grouting tests, they were chosen the chemical grouting and the material which is going to be used for the excavation of the station. So here's the photo from the geological survey. The last station is Náměstí Míru. It's again the interchange between line D and the existing line A. What is in this case interesting, that the new station is going to be constructed above the existing line. So the longitudinal section of the station. Here the original Metro Line A station, and here the huge one, Metro Line D station. Here's the layout of the surface to be shown. And the subsurface. So there will be a cross between the line A station and the line D. Here the change between the line D and line A stations. And here the cross section is again the single wall station, so it's quite big. Crossing with the A line and crossing with the escalator tunnel. So I'm coming to the last part of this presentation. Maybe I will answer the questions. The last question is,
Yes.
what are approximately geomechanical properties of the shale? It's not easy to answer. They are quite different, I would say, because you have, as I mentioned, you have different shale formations in Prague. So it does not depend only on the weathering degree, but also on which shale formation it is. So you have, for example, latent shale, which is very, very competitive rock, and the elasticity modulus of this rock is approximately 100-500 megapascals. And then you might have another shale, which is not so competitive, and the elasticity modulus of this shale might be only 60 megapascal. So when I say shale is everywhere in Prague, there are a lot of types of shale you can encounter during excavation. So let's go back to the TBM excavation. I will talk shortly about the design principles for urban TBM tunneling. Then I will say something about the cross-section, alignment, longitudinal section, starts and launches of TBMs, and as the last point, the excavation under the railway. So when tunneling in urban area, you have some key processes to be conducted very good to stabilize the tunnel face, to stabilize the backfill grounding, and to put segment lining. And in urban area, the goal is the stability of the front and the surface. You have there the interaction between TBM and the ground. You have the face pressure, grouting pressure, and the shield gap pressure, which is somehow communicating between pressure P1 and P3. And we have a limit for surface settlement. So we are trying to operate or design the operation of the TBM to get the volume loss lower than 0.5%. To that, we have defined face pressure for the entire excavation stretch to allow this very low settlements to be obtained. Another requirement for the successful EPB TBM excavation is the good earthmark. Again, the slump test, good workability, and these good properties are necessary to apply the calculated face pressure at the tunnel face successfully without settlements. We consider to employ widely observational method during TBM tunneling. So there is some excavation design for some setting for TBM. It's going to be coupled with monitoring. Trigger values for operation parameters are going to be defined, and these going to be verified. What is important, we designed the monitoring layout in that way that always before passing some critical infrastructure, there will be test field that you can test the setting of your TBM if it's appropriate to obtain low settlements. The cross section. We have excavation diameter about 6.1 meters. The internal diameter of the lining is 5.3, and the thickness of the lining is designed as 250 millimeters. The entire excavation will be about 4.8 kilometers, which is now under the tender. And the TBM should be capable to excavate both in soft and hard rock and also in soil. Yeah, the cross section will inhabitate also the concrete track slab for the subway, evacuation ramp on the left, cable ducts, and other constructions like service ramp and also rails. To the alignment, it all will start in the construction pit, and first the excavation will be done under the fields. Then we start to excavate under urbanized area, but there will be just only family houses, so no any high-rise buildings. What is necessary to say that here there should be in the next package constructed in the SS stations. So, but it will be constructed after this TBM package. So you first in this package you construct the TBM tunnels, and then you come with cut and cover methods, and you have to disassemble the segment lining and establish the cut and cover station. This solution was not chosen by the engineers. This solution was unfortunately chosen by the fact that the town does not yet own the area for the construction of the station. So they have to discuss it with the private owners, and in order not to cause any delay of the construction, we decided to adopt this approach. So we are coming with TBM to the station Nové Dvory. And after the station Nové Dvory, there are going to be high-rise buildings but there will be cover more than 20 meters in quite competitive rock. So therefore the settlements could be quite low. So there are some other questions. What are the expected piezometric pressures at the tunnel elevation? As I said, we have in this shale of Prague very different geotechnical conditions. But so it's quite hard to determine the groundwater level as in the soil. So what we are counting with is above up to 2 bars of groundwater pressure, no more. So again, the geology, you can see shale. You have here, but you have a different type of shales in Proterozoicum and in Ordovik, which is interfaced by Zavitsky shift. You have abrasive layers. You have very abrasive layers, but you have also not abrasive layers. And for instance, RQD is very variable. So you can have shale with RQD like 70, but about 70% or 80% of the excavation is through the shale with RQD around 0. But on the other hand, you can have in the shale, or especially in this Proterozoicum shale, quite high UCS. So this is, for example, 50-60 megapascal. And now I'm coming to the starts and moving of TBMs. The TBM will launch in the construction pit. On the right side, there will be just ordinary start of the TBM from the pit. On the left side, there will be start of the TBM from a cavern. It's again due to the layout of the other stuff around the pit. Here is a road. So, and here are some very important water pipes with diameter 1,200 millimeters. So this is the main water pipe delivering water for the city of Prague. So nothing can happen to that during excavation. Here are some cross sections for the launches of TBMs in the pit. Here in the cavern. Here again also in the cavern. again before the starting the area in front of the face will be grouted to enable the start. Here through the station Nové Dvory, as there was a question, here's the designed pulling of the TBM through the station. There is a design such a bed for pulling the TBM through the station. So the excavation under the railway, we have here just at the end of the excavation, as the last point, we have to underpass a railway under operation. This railway under operation is about 5 meters above the tunnel, above the TBM tunnel, and is completely located in soil. So the as tough conditions as you can imagine. And another requirement is that this has to be under operation. At least 2 tracks should be operated all the time. So we decided to establish a big grouting campaign. For this purpose, we designed 2 shafts, and here is the construction pit. So we will grout this area from horizontally from both sides, and they will be used for the soil jet grouting, and for the interface between rock and soil, some chemical grout for the rock. These shafts, before the arrival of the TBM, will be filled with poor concrete, but still in this area you can do the atmospheric intervention before the excavation of this very complicated stretch. So here again the grouted bodies, which are planned to be constructed before the passing of the TBM. Yeah, as I said, to answer this question, what type of grouting is foreseen for the TBM start? For the TBM start, we use mostly cement-based grouting. And here, when arriving with the TBM to the shaft, after that you will pass only through the grouted body until the end of the excavation. There are some dimensions of the grouted body, about 1.5 meter to the sides, and 2.5 meter above the tunnel ground. So I'm at the end of the presentation. This is the Czech greeting of the miners, Zdař Bůh. And I would thank for your attention. And if there still be some question, I'm ready to answer them.
Thank you so much, Zdeněk. I think Werner, he asked lots of questions. I do have a question. Why did you choose an EPB? What was the criteria to choose an EPB instead of like, what about mixed shoot?
Yeah, the reason for that is that we have this shale in Prague, and it has a lot of fines. And when this shale, certain type of this shale, when they are under impact and under mechanical impact and under impact of water, they are decomposing, and they are decomposing into fines.
But is
So
clay
in these conditions, there is much favorable to operate EPB than slurry, and it's also cheaper. That's another benefit.
okay? But in these fines, are there clay minerals or?
Yeah, they are clay minerals.
Okay.
Sometimes they are clogging, sometimes not. It depends.
Okay. Okay.
But it's not so. It's not so very. I would say not so problematic clogging as you can expect on other construction sites. This clogging is you can handle that. Sometimes you wash the TPM and that's it. Like add some anti-clogging agent, and That's it.
So Werner also asked if there's like maybe you have some swelling shales or
No, thanks God they are not swelling.
okay.
That would be another problem, but it's not happening.
Okay. And regarding to the first project, what I found interesting is that you actually expose the three options, no? Like, oh,
Mm,
you pass through here and through there and through there. I'm just thinking that here people do not really know exactly where it's going to pass through, exactly, oh, it's going to pass under my house. Like I get many people asking me, is this TBM going to pass under my building, close to my building? And nobody knows really where it's passing. The public does not know.
mm.
So it's I found interesting that they actually ask the public there, and of course, like everybody know, you shouldn't pass under my
Yeah,
freezing things.
there's a problem. We are trying to get the public feedback about the projects, but the most feedback what we get is usually not under my backyard, and uh,
Exactly.
and and you can do the tunnel wherever you want, but not under my house.
Yes,
So
but that's the point. Do you need to ask? Is there some reason why you have to ask?
um,
Why?
legally not. But of course, we would like to have that this project has a public acceptance. So there aren't like demonstrations against the project and like that the people are happy about the new project and not trying to fix their self to the construction machinery or whatever.
Yes. Okay. And when is expected that to start? You have an idea?
This railway tunnel is expected at 2025. But
Okay.
it's very positive expectation for the construction works because we still have not yet the zoning decision.
Okay.
So I think it's going to be delayed. But the metro line, as I said, part of that is already under construction. The second part is under the tender, and there should be within next year there should be found a contractor for the construction of the TBM part.
Okay. And last question I have, if anybody has any question, please, the time for you to type it's now. Otherwise, I want to ask something. Did you notice any difference, like regarding with the war in Ukraine? Like, did it change anything towards like the project tendering
Um, yeah,
time?
everything you have here in Czech Republic quite high inflation rate. So all the all the all the expectations about the costs of projects are over. They change a lot, and also there was a problem within this year to get some steel. There was no steel,
Okay.
and was not easy for construction companies to obtain the materials.
So probably the prices are quite high for steel.
Yeah, yeah, still quite high.
Influences a lot in starting anything. Okay. Oh, I hope it gets better. I hope you have
Hopefully,
enough warm there during winter as well.
hopefully,
And
hopefully.
thanks a lot for sharing with us these two projects. I
You are
find it
welcome.
interesting.
I
So
just maybe I interrupt you. I just forgot about one thing. If I could share quite
yes,
fast my screen.
yes.
Uh,
To
I
tell about
forgot. I
the
forgot
yes.
to tell about the conference, which is going to be next year in Prague. So it's going to be in May. It's focused on the underground construction, and it's always very nice conference, international in English. So you are welcome to submit abstracts. You can submit on the topics of mechanized or conventional tunneling. Just check the website, and you can see the options. So
That's great. It's a beautiful place, and it's just after Greece. So if people can just
yeah,
stay a little bit longer in Europe and just go to Prague.
yeah, definitely. For instance, if you like traveling, first you visit Athens, a
Yes.
conference in Athens,
You
ancient
wait
Greece.
2 weeks.
Then you come to Prague, to medieval town. So very nice trips.
Yes, that's a good idea. Great. So hope to see you in Greece. Thanks a lot in the name of CBT. And yes, we will have just a quick remind to the Brazilian colleagues that we have the tunnel day on the second. That's a Friday. That's going to be the third Brazilian game in the World Cup. And then we are going to have the tunnel day presentation in the morning. And I'm going to share the link that you can sign up for this event if you like to attend. So we have in the morning the tunnel day, and we have a lunch together, and we're going to watch the game. If you're invited to join, you get some t-shirts from CBT. That's what I heard. You get some snacks and so on and so on. That would be very nice. So that's Friday the 2nd. That's our next event. So thanks a lot, Zeynep. That was a
You're
pleasure to
welcome.
have you here. Thanks everyone that could attend. This video is going to be available. Please do not forget to subscribe and like. Thanks a lot. Good night. Bye
Thank
bye.
you. Good night. Bye bye.